Hey guys, so here's the answers to the worksheet due today. Um, Posting in a little bit will be actually posting at the exact same time as this will be worksheet number 2 due tomorrow. Basically more of the same, except there's a couple liter to mole calculations. I'll get into that after I go over this. All right, here we go. So, whoops. Nope. This thing is okay. So I'm actually gonna want to do this. All right, here we go. So first one, given the reaction N2. Okay, so our mole ratio here. We'll use I don't know. We'll use pink today. Why not? So make it a little bit bigger. All right. Mole ratio here is 1, 3, 2. So 1 to 3 to 2. What is the ratio of moles of H2 consumed? So H2 consumed to the moles of NH3 produced is 3 to 2. 3 to 2. So that's the answer to A. B, what is the total number of moles of N2 needed? So N2 to react with 4.5 moles of H2. All right, so we don't care about NH3. You know what? Let me clear that so it's a little easier here. So all we care about is N2 and H2. We do not care about NH3 in this problem. So how many moles, or what is the total number of moles of N2 needed to react with 4.5 moles of H2? So we look at the mole ratio between N2 and H2. So N has a 1 in front of it, and H2 has a 3. So it's 1 to 3. My 1 is N2. My 3 is H2 equals, so if we're going to have moles of N2 on top, we need moles of N2 on top. If we have moles of H2 on the bottom, we need moles of H2 on the bottom. So if I know 1 reacts with 3, and that's how this reaction works, that's the proportion that makes this work. So I have to keep that 1 to 3 ratio. So if I change my hydrogen to 4.5, so again, imagine this number is 4.5 now. What does this number have to be to keep the same ratio, the same proportion? So 1 is to 3 as x is to 4.5. So we cross multiply. 4.5 equals 3x. Divide by 3. Divide by 3. X equals, what is that, 0.75? Let's see here. Oops. 1.5. Sometimes in the morning my brain's not working. 1.5 moles is the answer to number 1. 1.5 mole, which makes sense. If 3 goes up to 4.5, 1 will go up a little bit to 1.5. Oh yeah, couldn't have been 0.75. See, I'm still asleep apparently. So if you're listening and following, I said, oh, what is that, 0.75? Well, that's impossible, because if this goes up, this has to go up, right? So I wasn't thinking. All right, here we go. Letter C. How many moles of H2 are required to produce 0.75 moles of NH3? So now we care about H2 and NH3. We don't care about the N2. So we look at our mole ratio in the balanced equation. So I know 3 moles of this are required to make 2 moles of that. So if 3 makes 2, right? 3 makes 2. So here's my H2. Here's my NH3. Then how many are needed to make 0.75? Right? So if I know 3 moles makes 2, how many make 0.75? So if this number goes down, this number is going to go down. Cross multiply. 2x equals, I think that's 2.25. Yep. My brain's starting to work a little bit better here. 2.25 divided by 2, divided by 2, and it equals 1.125 mole. Oops. Jeez. 1.125 moles. There we go. That's the answer to letter C. Okay, so that's A, we did B and C. I'm going to take a new screenshot here and move on. Okay, so there's that. Let's see if we can do... All right. Here we go. All right, so now we got N2 plus 2O2 yields 2NO2. What is the total number of moles of oxygen, so we have oxygen, needed to react completely with 1.5 moles of nitrogen? So again, here we don't care about that. It's just the 1 and the 2 here. So it's a 1. Well, here, you know what? I'll do it in the order they're asking. So moles of oxygen goes on top. That's going to be 2 moles of oxygen divided by 1.5 moles of nitrogen. 1.5 moles. Not divided by, but that's my mole ratio. It's 2. No. Sorry, guys. Back up. What is the total number of moles of oxygen need to react completely 1.5 moles of the nitrogen? All right. So what I want to do is use my mole ratio in the equation. So it's 2 to 1. So 2 to 1. Sorry, guys. 2 to 1 is how many moles? What is the total number of moles? X moles of O2 to 1.5 moles of N2. So again, with the same thing over and over here with these types of problems is they're going to give you two parts of the equation, two reactants, a reactant and a product. You're going to use the mole ratio in the balanced equation. That's always this side. And then this side is going to have the new variables, the new numbers. The question is going to give you one of the numbers. The other one's going to be an X. So if we know 2 reacts with 1, then how many moles react with 1.5? So if we turn the 1 into a 1.5, then the 2 is going to increase as well. So we cross multiply, X equals 2 times 1.5, 3 moles. That's the answer for number 2A. 3 moles of O2. Okay. How many moles of O2 will 3.75 moles of KClO3 produce? So now, again, we don't care about this one. We care about the 3 and the 2. How many moles of O2 will 3.75 moles of KClO3 produce? All right, so it's 2 to 3 equals, and again, my 2 is KClO3. My 3 is my O2. So over here, it's the same thing, KClO3. O2. All right, how many moles of O2 will 3.75 moles of KClO3? So 3.75. Okay, so again, I'm taking my O2 and my KClO3. That's a 2 to 3 ratio, 2 to 3. So if 2 moles makes 3, 3.75 moles will make X. So if this goes up to 3.75, this is going to go up to something. Here we go. So 3.75 times 3. 3.75 times 3, we get 11.25 equals 2x. Divide by 2, x equals 5.625 moles. And this might be hard to see, actually, now that I look at it, but we'll switch the color up. So there's 3A. All right, 3B. Let me get a new thing here. Yeah, let's see if this works. All right, I should be able to squeeze that in there. All right, here we go. Let's do a different color. We'll go this one. All right, calculate number of grams of KClO3 needed to produce 5 moles of KCl. All right, so KClO3, KCl. So it's 2 to 2. So this one's actually easier than it looks. So if my mole ratio is 2 to 2, whatever I change the KCl to, or whatever I change the KClO3 to, the other one will change exactly the same way. In other words, we could set up a proportion, and I'll show you. It's 2 to 2, but it's kind of silly. When they're the same number, you don't need to do the math. So if this one up here is KClO3, this one here is KCl. and we change the KCl to a 5, well, this one's also going to be a 5, right? So we could put an X there, but really that's 5. If it's 2 to 2, 1 to 1, and this is a 5, then that's also a 5. So we don't really need to do that math like we've been doing. So basically, if we know we want to make 5 moles of this, that means we have to start with 5 moles of that. Why? Because 2 makes 2, so 5 makes 5. All right, so I know I have 5 moles of KClO3. Let me make this a little smaller. And we'll go 1. Okay. So now it's more of what we did last week. We convert moles to grams. So we have to find the gram formula mass of KClO3. Let me rewrite this a little bit better. So KClO3. All right, so K has a mass of 39 grams. Cl is 35 grams. And each oxygen is 16. So 16 plus 16 plus 16 is 48 grams. So if we add those together, I want to say it's 106. Sorry, guys. 39 plus 35 plus 48. 122. 122 grams per mole. Remember, now that tells us if we have 122 grams of KClO3, that means we have 1 mole, right? Well, we have 5 moles. So how many grams is that equivalent to? So if 122 are in 1, this number is going to be 5 times higher, right? Cross multiply, 122 times 5, 610 grams is the answer. There we go. All right. I was going to put some notes in this video, but I'm going to stop this, publish this one. I'm going to give you 2 examples to help you do number 5 and 8 on the homework due tomorrow. So I'm going to close this, stop recording. I'll be back in a minute.